Welcome back to Things I Know Nothing About. I'm Alex.
And I'm Maya. So, Alex, I've been seeing rocket photos all over my feed this week, and I need you to tell me, are we actually going back to the moon?
We really truly are. NASA rolled the Space Launch System rocket out to the launch pad at Kennedy Space Center in mid January 2026, and right now they're prepping for a wet dress rehearsal, basically a full fueling and countdown test without actually launching.
Okay, wet dress rehearsal is an incredible name, but let me get the headlines straight. The last time humans went anywhere near the moon was 1972?
December 1972, Apollo 17. Gene Cernan was the last person to walk on the lunar surface. That's 53 years ago, and Artemis II will be the first crewed mission back to lunar space since then.
53 years. My parents weren't even born yet. Why on Earth, or I guess why off Earth, did it take so long?
Money, politics, and a whole lot of canceled programs. After Apollo, NASA pivoted to the Space Shuttle and the International Space Station. Both were incredibly ambitious, but they kept us in low Earth orbit.
So we basically traded the moon for a really nice apartment 250 miles up.
That's a pretty accurate analogy, actually. The shuttle flew from 1981 to 2011 and cost roughly $200 billion over its lifetime. There just wasn't budget left for deep space.
Were there ever plans to go back sooner?
Several. George H.W. Bush proposed a moon base in 1989. Congress killed it over cost. George W. Bush launched the Constellation program in 2005, building an Orion capsule and a new rocket called Ares. Obama canceled Ares in 2010 but kept Orion. Then Congress mandated the Space Launch System as Ares' replacement, and here we are.
So Orion has survived 4 presidencies to get to this point. 20 years of development.
And the SLS rocket traces back even further. Those RS-25 engines, the solid rocket boosters, the big orange tank design, they're all evolved space shuttle components. Reusing that industrial base meant Congress kept the funding flowing because the job stayed in the same states and districts.
All right, so the rocket is on the pad. Walk me through what happens when they light the candle.
So Artemis II is a 10-day mission. 4 astronauts launch from Kennedy Space Center's Pad 39B, the same complex that launched Apollo missions, by the way. The crew is Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen.
Tell me about the crew. Anyone making history?
All 4 of them. Victor Glover becomes the first person of color to travel beyond low Earth orbit. Christina Koch will be the first woman to fly around the moon, and Jeremy Hansen, a Canadian Space Agency fighter pilot, becomes the first non-American to go that far from Earth. Now, the mission profile is fascinating. They use what's called a multi-trans-lunar injection, multiple engine firings while still in Earth orbit to build up speed rather than one big burn.
Why not just one big push?
It lets them thoroughly check out the Orion spacecraft systems in a relatively safe environment first. If something goes wrong in Earth orbit, you can come home quickly. Once everything checks out, they commit to the final burn toward the moon.
Smart belt and suspenders.
Then they follow a free return trajectory. That means the path they're on uses the gravity of the moon to sling them around the far side and back toward Earth automatically. Even if the engines failed completely after that final burn, gravity would bring them home.
Like Apollo 13.
Precisely the same principle. They'll swing about 6,400 miles behind the far side of the moon, farther from Earth than any human has ever traveled. When they come back, Orion hits the atmosphere at roughly 25,000 miles per hour. Mach 32.
My brain refuses to process that number. 32 times the speed of sound.
And that reentry is one of the most critical things they're testing during Artemis I, the uncrewed test flight in 2022. The heat shield experienced unexpected charring. Chunks of ablative material came off in ways engineers didn't predict. They spent over a year investigating. The issue was related to gas flow through gaps in the heat shield during re-entry.
The heat shield had problems and they're still sending people.
They've made modifications and done extensive ground testing, but Artemis II will be the real proof with humans aboard. That's partly why this mission exists, testing life support, navigation, communications, and especially that heat shield before you attempt a moon landing. The crew will manually fly portions of the mission, verify the ECLS life support system, and confirm communications work at lunar distance. No landing, no lunar orbit, just a loop around and straight back.
Not a joyride, a genuine test flight. Okay, so when do we actually land someone on the moon?
That's Artemis III. NASA officially targets mid-2027, but realistically, most space analysts expect it closer to 2028 or even later. SpaceX's internal timeline reportedly has a crewed lunar landing attempt around September 2028.
Why does SpaceX matter for a NASA mission?
Because the lunar lander for Artemis III is SpaceX's Starship, specifically a variant called the Human Landing System, or HLS. The plan is wild. Orion flies the crew to lunar orbit, then they transfer into a Starship that's already waiting there, ride it down to the surface, do their moonwalks, ride Starship back up to orbit, transfer back into Orion, and fly home.
Hold on. A whole Starship has to be parked in lunar orbit waiting for them.
Yes, and getting it there is the hard part. Starship can't carry enough fuel to reach the moon on its own, so SpaceX has to do orbital refueling first, launching a tanker version multiple times to fill up the lunar Starship in Earth orbit before it heads to the moon.
How many refueling launches are we talking?
Somewhere around 10 to 15 tanker flights. SpaceX is supposed to demonstrate propellant transfer by mid-2026, then do an uncrewed Starship lunar landing by mid-2027. Neither has happened yet, and that's before the spacesuits. Axiom Space is building new moonwalking suits called the XEMU, far more advanced than Apollo suits with better mobility, longer life support, and built-in HD cameras.
Lunar dust was one of the worst Apollo problems, right? Got into everything.
Gene Cernan called it one of his biggest concerns. The stuff is like tiny glass shards, no weather to erode it smooth. It jammed zippers, scratched visors, irritated lungs. Modern suits have to solve that.
Where would they actually land? Same spots as Apollo?
The lunar South Pole near Shackleton Crater. It's scientifically fascinating because permanently shadowed craters there contain water ice, places that haven't seen sunlight in billions of years.
Billions of years of darkness. That's eerie, but also useful.
Incredibly useful water ice means drinking water, breathable oxygen, and even rocket fuel, all from lunar resources. That's the whole premise of sustainable exploration. You don't ship everything from Earth, you learn to live off the land.
Okay, I need a palate cleanser from rocket anxiety. What else is happening in space news?
Something that might actually be more revolutionary in the long run. In January 2026, NASA announced the selection of industry proposals to advance technology for something called the Habitable Worlds Observatory, HWO for short.
That name sounds like it belongs in a science fiction movie.
It's the most ambitious telescope concept NASA has ever proposed. The goal is to directly photograph Earth-like planets orbiting Sun-like stars and then analyze their atmospheres for signs of life.
Directly photograph them? Webb can't do that?
Webb has imaged a few giant exoplanets, Jupiter-sized worlds far from their stars, but an Earth-sized planet in the habitable zone is billions of times fainter than its star. Picture spotting a firefly next to a lighthouse from 1,000 miles away.
How would any telescope pull that off?
Two key technologies: a massive mirror, 6 to 8 meters, comparable to Webb's 6.5. But the real magic is a next-generation coronagraph, an instrument that blocks the star's light with incredible precision so you can see the faint planet beside it.
Like holding your thumb over a bright light to see what's next to it?
Similar concept, but the engineering is thousands of times more precise than anything we've built for space. NASA says the coronagraph needs to be thousands of times more capable than any space coronagraph ever flown, and the optical system has to remain stable to within the width of a single atom during observations.
The width of an atom. Any vibration bigger than that ruins the image.
Completely. That's why NASA just awarded contracts to 7 companies: Lockheed Martin, Northrop Grumman, L3 Harris, BAE Systems, and others, for 3 years of critical technology development. Launch is probably late 2030s or 2040s at the L2 point, like Webb. But unlike Webb, which was designed as untouchable, launch it and pray, HW would be built for servicing and upgrades in space. New instruments, new cameras, even mirror repairs.
Learning from Webb's please don't break philosophy. Smart.
The science potential is staggering. The goal is to characterize at least 25 potentially habitable worlds. If you find oxygen, water vapor, and methane in the same atmosphere, that combination is really hard to produce without biology.
Not little green men, but actual evidence of alien biology.
Chemical biosignatures in an exoplanet atmosphere, not a picture of an alien waving, but the fingerprint of an entire biosphere. NASA Administrator Jared Isaacman called it the kind of bold, forward leaning science that only NASA can undertake.
That gave me actual chills.
To bring it all together right now, there's a 322-foot rocket on a Florida launch pad getting ready to send 4 humans around the moon for the first time in over half a century. And simultaneously, engineers are designing a telescope that could find life on another world.
Both of these have felt almost ready for so long that part of me can't believe they're really happening.
That skepticism is earned, but the hardware is physically on the pad, the crew is trained, the countdown is coming.
What gets me is the human element. 4 people looking out a window at the far side of the moon, closer than anyone in 5 decades. The first woman, the first black man, the first Canadian. That matters alongside the engineering.
We'll absolutely cover the launch when it happens. Thanks for listening to Things I Know Nothing About.
See you next episode.